All right, guys, we're going to take a quick look at fractions this week. So we're going to go back and remind people how to find equivalent fractions and also how to be able to switch between mixed numbers and improper fractions. Knowing those two skills will really help you with all the math that we do in 5th grade with fractions. So we can start off very easily taking a look at a simple fractions like 1/2. Now, for starters, we could do this picture way. So if we're looking for an equivalent fraction, we could take a look and we could say, all right, well, we have 1/2. So 1/2 represented in picture looks something like that, 1/2. Now, if we're looking for an equivalent fraction, we're looking for something that's the exact same size, but a different number of pieces. So I can just write underneath it, I'll make something that's the exact same size, roughly, for as good of an artist as I am. All right, so there's my 1/2 again, but now maybe this time I'll cut it like this. So now, seeing it, I've got 2 out of 4 pieces that are shaded in. So 2/4 would be my equivalent fraction right there. Notice it's still the same amount total that is shaded in before. This piece right here is equal to this piece right here. It's just more pieces now than what there was before. Okay, and I could do that as many times as I want to. I could do the same piece again. Here's my 1/2, and I could chop it this time maybe into 3 pieces. So now I have 3 out of 6 pieces. Okay, so notice when we are finding equivalent fractions, both the numerators and denominators are changing. So that's really important because when I cut this apart, I doubled the amount of new pieces that were shaded, but also the total number of pieces. Same for when I cut it into 3 or tripled it. I tripled the amount of pieces that are shaded, but I also tripled the total amount of pieces. Now, for some of you, you should be at the point where we can start looking at it more numerically. So we could just take the 1/2 and we could multiply it by something instead. Now, the biggest mistake 5th graders always make is they say, oh, well, we'll just multiply it by 3. Okay, well, if you multiply it by 3, you're going to get 3 groups of 1/2. I don't want to do that. What I really want to do is I want to multiply it by 3/3, 3/3. 3/3, as we all know, is the same thing as 1/2. So really, I'm multiplying 1/2 by 1, which means that it's not going to change. I can multiply anything by 1 without changing it. But what does change when I multiply straight across is 3/6 is I've done this. I've cut it into those 3 pieces. I've tripled the amount of pieces that were shaded. I've tripled the total number of pieces. I have the exact same amount, okay, but it's in a different form, okay? That's our basic way of finding an equivalent fraction. And we can do it with any fraction. So I can do it with, I don't know, let's do it with 5/7. And I can multiply 5/7 by 8, okay? But if I multiply by 8, I really want to multiply it by 8/8 because I want to multiply it by 1 whole unit. So 5/7 is equivalent to 5 times 8 is 40, and 7 times 8 is 56. So 5/7 is the same thing as 40/56, okay? So that's our very quick way to find an equivalent fraction when we're looking for one. This becomes very helpful when we're adding or subtracting fractions with unlike denominators because you can't do that until they do have an equivalent fraction, the same denominator, okay? Now, with this, oftentimes what we'll also have to use equivalent fractions for is when you come to an end answer, you might end with something like 24/30, okay? And in the real world, 24/30 is a daunting fraction to use. I don't ever want to cut something into 30 pieces unless it's a big sheet cake or something like that. But in general, a piece of wood, something like that, I don't want to cut it into 30 little divisions to find it. So you're going to want it in a simpler terms. So I can take the same concept that I just did with multiplication, except this time I'm going to divide it by something. Now, 24/30. I would look for something that both of these things have in common. So if I know my multiplication facts, I could go through real quick, and I know that 24 is, I can get to it by doing 1 times 24, 2 times 12, 3 times 8, 4 times 6, and then I can look for 30, and I could do the same thing. And I look for one factor that they both have in common. Doing that, I would know that they both have 6 in common. Now, when we multiplied, we made sure that we did it to both pieces, the numerator and the denominator, because we didn't actually want to change the size. That's true for division as well. I want to do it to the top and the bottom. If I just divide it by 6, okay, then I'm only changing the numerator. I'm breaking it up into 6 equal size pieces. I want to divide it by 1 because it'll be the same thing. So I'm dividing it by 6, 6. So it works the same way. 24 divided by 6 is 4, and 30 divided by 6 is 5. 24/30 is equal to 4/5. That's a much more manageable fraction that we could actually use in the real world. And let's face facts, when you're on a test or a quiz, they're probably not going to give it to you in that form. They're going to give it to you in the simplest forms. So when you get problems or answers like this, you're probably going to need to be able to see the relationship between 24/30 and 4/5. That comes up often. All right, now real quick, while we're at it, we're going to take a look at mixed numbers and improper fractions as well. So when we're doing mixed numbers and improper fractions, mixed numbers refers to having a whole number with a fraction, okay? That's a mixed number. I've got wholes and a fraction with it, okay? That's the mixed part. An improper fraction is any fraction where the numerator is the same size or larger than the denominator. So something as simple as 5/4, where my numerator is larger than the denominator. So this is my mixed number and this is my denominator. They both have different purposes. You might want one in one form one time, and then the next time when you're working with it, you might need it in a different form. So we do need to make sure that we know how to change between one form to the other. Now, for me personally, this is the easiest one, changing it from an improper fraction to a mixed number. Because we've talked about it, a fraction is just division. So I'm looking at what's 5 divided by 4. So if I'm thinking about it, how many times does this 4 go into 5? Well, 5 divided by 4, it goes in one time. So I could make one whole. And then if I think about it, if I take 4 pieces away to make that, there would be 1 left. So I'd have 1/4 left. Now, all of my doubting Thomases out there who look at it and say, what? That's so fast. I don't know what he did. Take a second and think about it. If I had 5/4, so here's one whole, there's divided into fourths, and I have another whole divided into fourths. Take a look. That's 1, 2, 3, 4, 5/4 broken up. Look, I've got one whole and one extra fourth. Okay, so you can do it as a picture as well. Now, for me, slightly more complicated is changing your mixed number into an improper fraction. Now, it might be easier for you, just a little harder for me. So I'm going to take my whole number and I want to break it into this denominator. So I need to take those two wholes. Okay, wow, that is a horrible rectangle, but it'll work. So I take these two wholes and I'm going to break them into halves. And I'm going to see how many it made. So it made 1, 2, 3, 4. It made 4 halves. Now the common mistake that people generally make is they forget there was already one here. So these two wholes broke up and made 4 halves. There was already 1 half there. That means I now have 5 halves. Okay, the 1 half here and the 4 that I just made. Okay, now that's a quick picture form. You can also do it as a shortcut way using multiplication. So let's say I'm doing 3 2/3, and I would like that as an improper fraction. Okay, when I draw these 3 rectangles to break them up into thirds, each one is going to make 3 pieces, right? Because I'm breaking it up into thirds. So I'm going to get 3, 6, 9. I could have gotten the same thing by just doing 3 times 3 is 9. Okay, so that's a quick shortcut that we are already familiar with this year. So when I change this 3 wholes into thirds, I'm going to get 9 of them plus the 2 that's there. So 9 plus 2 is 11 and 11/3. Okay, it's up to you whether you need the picture form or whether you want just numbers. Both are very effective. The larger your denominator or the larger your whole number is, the harder it's going to be to do a picture. So I would really recommend working on getting to the point that you can just look at it numerically and do it that way. Well, we've got a lot of practice doing it this week. So today Monday, you're going to have problems where you're going to have to simplify, find equivalent fractions, convert between improper and mixed numbers. And then all week when we're working with adding and subtracting fractions, these are going to be skills that you're going to need to use to be able to just solve basic problems. So if you're having any trouble with it, make sure you stop in and talk to me during the day. Thank you.